Is the product of 3 square roots of 5 times 2 square roots of 3 rational or irrational? In this lesson, you will learn how to multiply rational and irrational numbers by defining each. The general rule for radicals are the same as for anything else. If you want to add or subtract, you must have the same size and type of term. If you want to multiply, you can combine any size or type. A coefficient tells us you have the total number of groups or parts you Is the product of 3 square roots of 5 times 2 square roots of 3 rational or irrational? In this lesson, you will learn how to multiply rational and irrational numbers by defining each. The general rules for radicals are the same as for anything else. If you want to add or subtract, you must have the same size and type to combine the terms. If you're multiplying, you can combine any size or type. A coefficient tells you the total number of groups or parts that you have. In this case, this represents 2 squares. Rational numbers are those that can be written as ratios of integers. They can be easily identified if they can be written with repeating decimals. Irrational numbers cannot be written as ratios of integers and cannot be written with repeating decimals. You recall that a rational number times a rational number is still rational. Let's say that a, b, c, and d are all integers. That means that a over b and c over d represent rational numbers, x and y respectively. Since two integers multiplied together give you another integer, you have integers on the numerator and integers on the denominator, so this a, c, b, d is rational. If that's true, then x, y is also rational. So irrational times irrational is rational. Sometimes you can't draw a physical model with blocks when you multiply, but you could set up an array by looking at the parts. Here, if I want to multiply 3 square roots of 5 times 2 square roots of 3, I'm looking at the first term, which tells us we have 3 of size square root of 5. The second term says I have 2 lengths of square roots of 3. Let's multiply these in an array and see what happens. When you multiply, you add on dimensions, so you'll turn the corner just as if I was multiplying 3 times 2. If I complete the rectangle and then multiply the square root of 5 times the square root of 3, I get the square root of 15. In your model, you can see that you end up with 6 of these, so your final answer would be 6 square roots of 15. But you have to ask yourself at this point, can I write this answer as a ratio of just integers? In this case, no, you can't. So an irrational number times an irrational number is irrational. Let's practice one more just for good measure. Here we have 3 square roots of 2 times 4 square roots of 18. Again, we can write this out in an array. As we write out our rectangle, on the left we see the square roots of 2, on the bottom we see the square root of 18, and when we multiply the square root of 2 times the square root of 18, we get the square root of 36. Here we have 12 of them, which gives us 12 square roots of 36. You have to ask yourself again, can you write this as square root of 36 as a ratio with just integers? Well, we know that the square root of 36 is 6, so what we really have is 12 times 6, which gives us 72. But that's a rational number. This last slide said that an irrational number times an irrational number is irrational. In this case, we had an irrational number times an irrational number that gave us a rational number. So there's no guarantee in this one. Some of you may have also noticed that there could be a shortcut in this case, or in all cases when we multiply rationals and radicals. Here we have 3 times 4, and we multiply that and give 12 when we multiply the coefficients of the radicals. Now if we multiply the radicals, we have the square root of 2 times the square root of 18. That gives us a square root of 36. So we have 12 square roots of 36, just like before. Again, if you simplify, we end up with 72. What if you multiplied a rational number and an irrational number? So, 3 times 2 square roots of 3. The first term means that you have 3 lengths of size 1. The second term means that you have two lengths of size square roots of 3, and you can draw that. Let's multiply 3 ones times the square root of 3, and you get 2 square roots of 3, which gives you 6 square roots of 3. Ask yourself, can I write the square root of 3 as a ratio with just integers? No, you cannot. So in this case, I'm thinking that a rational times an irrational is irrational. But let's look at the general case just in case. With a rational times an irrational, let's say that x, y, c, and d are all integers, and I'm going to say that b is an irrational number. If you multiply x over y times b, x over y would be a rational number times the irrational number, and we're going to say that it equals c over d, which is a rational number. If I multiply by the inverse to get b by itself, I end up with b equals yc over xd. But we know that two integers equals another integer, so an integer in the numerator and an integer in the denominator gives us a rational number. So b equals a rational number. But we just said at the beginning that b is an irrational number, so this can't be true. If it can't be true, then a rational number times an irrational number must be irrational. In this lesson, you have learned how to multiply rational and irrational numbers by defining each.